Hi everybody, welcome back. So today we're going to continue with exponential functions, and we're actually going to be writing the equation of an exponential function given a table or graph. So just a reminder, exponential functions, make sure I'm on the right setting here, have the form y equals a times b raised to the power of x. So this is exponential because the exponent is our independent variable, x, and that exponent is attached to a constant known as b. Now in this case, in order for us to find a and b, a is going to be our y-intercept. So in order for us to find the y-intercept in a table, we're going to look where x is 0. If we want to find the y-intercept on a graph, we're going to look and see where our graph crosses or touches the y-axis. To determine b, our base, we're going to look for the common ratio. Now remember what that means. If we go back to geometric sequences, the common ratio was the number that we multiplied by to get from one value to the next. So in this case, when we're looking for the common ratio, we're going to take a look at our y values and see, well, how am I getting from one y value to the next? And if we can't figure that out right away, we're going to use some division to help us with that. So let's go ahead and get started. Write the equation of the function represented in the table. So looking at number 1, my y-intercept is right here. Here's my x value of 0. When x is 0, my y value is 3. So my y-intercept, don't forget, that goes along with the a term. So a is 3. Now b might be a little bit trickier. B is going to be found by looking at our y values and trying to figure out, okay, how are my y values increasing? What am I multiplying each y value by to get from one to the next? So if I look, 0.75 to 1.5, okay, how did I get there? It looks like I multiplied by 2. And then same from 1.5 to 3, I multiply by 2. From 3 to 6, I multiply by 2. From 6 to 12, I multiply by 2. So my b value is 2, because to get from one term to the next, I'm multiplying by 2. Now, if you couldn't see that, then you could do some division to help you with this. So working from the bottom of the table to the top, you could divide 12 divided by what gives me, or I'm sorry, 12 divided by 6 gives me 2. 6 divided by 3 gives me 2. 3 divided by 1/2 gives me 2. So you can always work backwards if you aren't sure what the b value is just by looking at it. So now that I have a and b, I can go ahead and write my equation for this exponential function. So y equals a. Now b I'm going to put in parentheses, raised to the power of x. Okay? And here is our exponential function for table 1. Looking at table 2, once again, I need to identify a and I need to identify b before I'm allowed to write the equation. So looking at my table, when x is 0, I see y is 6. Here is my y-intercept, which is also my a value. So a is 6. Now b, I'm looking for that common ratio. So what am I noticing is going on with my y values? Well, it looks like my y values each time are being cut in half. So instead of saying divided by 2, I'm going to say each y value I multiply by 1/2 to get from one to the next. So my b value here is 1/2 because 6 times 1/2 gives me 3. 3 times 1/2 gives me 1.5, and so on and so forth. Now that I have a and b, I can go ahead and plug those right into my equation. Now you can use 1/2 as your b, you can use 0.5, it is totally up to you. Either way is fine. Again, I like to put that b value in parentheses just to kind of break up my equation a little bit here and to make it a little easier to read. All right, let's keep going. Looking at number 3, I see 0, 2. So remember, when x is 0, that y value is going to be my y-intercept, which is also my a term. So a is 2. My b value, so this one's a little bit tricky. This one, I can't just really off the top of my head figure out what is going on here. So I'm going to do a little dividing to help me out. So starting from the bottom and working my way up, I'm going to divide. So I'm going to start with 0.2592, and I'm going to divide that by 0.432. So plugging this into my calculator, I'm going to figure out the common ratio by doing some division. So 0.2592 divided by 0.432 gives me 0.6. And I want to see if that is really the common ratio. So is that the same thing for each one of these values? So if I keep going, and I'm just going to do this on my calculator, I'm not going to write it down here just for the sake of space, but if I take 0.432 and I divide that by 0.72, oh, I get 0.6 again. And if I keep going, 0.72 divided by 1.2, I get 0.6 again. And then just to verify, 1.2 divided by 2 also gives me 0.6 as well. So our common ratio is definitely 0.6. Remember, this dividing only works if we have consecutive values. So when x is 0, followed by 1, followed by 2, followed by 3. If we tried to divide when x was 4 and x was 2, we're not going to be getting the same thing. So this only really works when we have consecutive values. So noticing that our common ratio is 0.6, that's our b, I can go ahead and write my equation. So filling in a and b, here's one way we could write the equation. If you wanted to make 0.6 into a fraction, you can do that as well. So we could say y equals 2 times, let's see, 0.6 as a fraction is 3/5. So either one of these would work. Okay. All right, looking at the next one, number 4. First thing I'm going to do is locate my y-intercept, which is right here. So that's my a value is 5. My b value, let's see what's going on. Let's see, it looks like, and I can really check it out from the bottom 3 points, make it a little easier for me to see. So from 45 to 15, it looks like we divided by 3. Dividing by 3 is the same as multiplying by 1/3. And that's the same with 15 and 5. Okay. All right, so writing my equation here, a times b raised to the power of x. Now, if you have a repeating decimal, make sure you turn that into a fraction for your b value. Please do not write like 0.3 repeating. You guys know what that is. It's 1/3. Go ahead and change that into a fraction just to make it a little easier to read when we write our equations. Okay, so that's basing our equation from a table. Now let's take a look at graphs. So in order to write the equation of an exponential function from a graph, we're going to create a table of values from the graph and determine the base b, which again is that common ratio. So b is our common ratio. And then the y-intercept of the graph is our a term. So again, this is when x equals 0 or when we cross or touch the y-axis. So looking at this graph, you want to make sure when you're making your table of values, so if I'm looking at number 5 here, here's x and y. When I make my table of values, I want to make sure I'm picking out nice, clear points. Now, remember, we know that these graphs, once we kind of hit where, you know, our graph is extending in one direction, it's kind of reaching that asymptote where we're getting awfully close to a value, but we're not touching it. We know that there's going to be a lot of decimals in our points there. Those we may want to avoid because it's going to be really hard for us to figure out what exactly that decimal is just by looking at the graph. So what I'm going to do is I'm going to pick points that I can very clearly see to help me write this equation. I don't need a ton. You know, 3 points, 4 points would be really, really helpful. But again, a minimum of at least 3 to help you write this equation. So if I'm looking at the graph in question 5, some points that I can clearly pick out. First being the y-intercept. That's definitely at 0, 1. Another point is located at 1, 2. So you'll notice there's this point here, this guy is pretty clear to see. So I'm just trying to pick out points where I can find real clear intersections to help me with this equation. So 2, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. So first thing I see, here's my y-intercept. So that means my a value is 1. The next thing I need to figure out is the common ratio. So what are we multiplying each of our y values by to get from 1 to the next? Well, 1 to 2, I would multiply by 2. 2 times 2 gives me 4. 4 times 2 gives me 8. So my common ratio, notice how we're multiplying by 2 each time here. My common ratio, or my b value, is 2. So knowing a and b, I can go ahead and actually write my equations. So it might actually look a little nicer. Let me just move this a little bit here. So writing my equation, I get 1. Again, put your b in parentheses just to break it up and make it easier to see that multiplication. And there we go. All right, let's take a look at number 6. So number 6, again, start with that table of values. Let's pick out some points that are very clearly written here. Yep. That one's a nice one. This one's nice. This one's nice. And then it might get a little crazy. Okay, so looking at the points that I've marked out, I see -1, 1, 2, 3, 4, 5, 6, 7, 8. I see 0, 1, 2, 3, 4, 1, 2, and 2, 1. Okay. All right, 0, 4. Here's my y-intercept. So a is 4. My b value, what are we multiplying by each time to get from one y value to the next? Well, from 8 down to 4, I divided by 2. Dividing by 2 is the same as multiplying by a half. Same here. Same here. So multiplying by 1/2, that's going to be our b value, or our common ratio. So writing our equation, y equals a times b raised to the power of x. Okay? All right, let's keep going. All right, taking a look at number 7. So just to review actually a little bit of what we did yesterday, if you're looking at number 7, notice how looking at this graph, this blue graph from left to right, our graph is increasing. As our x values are getting bigger, so are our y values. Remember, this is what we would call a growth, an exponential growth. If you look at number 8, reading our graph from left to right, you notice how as our x values are getting larger, our y values are getting smaller. This is actually a decay. So just something to point out to kind of bring in what we did yesterday. All right, back to today. Let's write these exponential equations here. Okay, so looking at number 7, I'm going to create a table. Some nice values that I can clearly see. And this one doesn't really have as many as we saw previously. Trying to get as many as possible in a row. This guy looks like it could be at a half. Oops, sorry. Pressing down too hard. Stop. Okay. All right. There we go. Okay, so looking at these first couple, I see 0, 2. I see 1, 3. And it looks like 2, 1, 2, 3. It looks like 2, 4 and a half. I think that looks pretty close. And then we continue going up from there. And I'm a little nervous to mark too many because, again, I want consecutive points to really help me figure out my b value. So looking at my table, 0, 2, that at least gives me A. All right, so I'm going to write this down here. A is 2. My B, all right, how did I get from one term to the next? How did I go from 2 to 3 or 3 to 4.5? Again, if you are not 100% sure, go ahead and do some division here and work backwards. So 4.5 divided by 3 gives me 1.5. Same thing if I go 3 divided by 2, I get 1.5. So now that clearly tells me my B value is 1.5. I'm multiplying by 1.5 to get from one term to the next. All right, knowing A and B, I can go ahead and write this equation, filling in those key pieces along with my variables X and Y. Looking at number 8. Oh, sorry, just one quick thing before I jump there. So notice how when we labeled this as a growth, in order for us to just verify that our answer and our thinking is correct, take a look at that B value. Notice how your B value is greater than 1. When that's the case, we do have an increasing graph, and an increasing graph does represent a growth. A B value greater than 1 is a growth. So our equation looks pretty good based on those facts. Now taking a look at our decay graph here in number 8, just picking out some key points here. And thankfully this one gives us a couple good ones right in a row. Again, you don't need many. 3 is a good number just to see. So looking first, -2, 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 3, and 0, 1. All right, so 0, 1, here's our y-intercept, so our A value is 1. Our B value, how did I get from 9 to down to 3? What did I multiply 9 by? Well, 9 divided by 3 is 3, but instead of saying divided by 3, I'm going to say multiply by 1/3, and same goes from 3 down to 1. All right, so my final equation here, plugging in A and B, gives me y equals 1 times 1/3 raised to the power of x. All right, which makes sense. 1/3 falls between 0 and 1 as far as your B value goes, and we know that that means this is a exponential decay. All right, number 9, we have another exponential growth equation. Picking out some nice clear points that are preferably in a row. Yep, we got 3 in a row. Excellent. Because again, when they're in a row, it just allows us to pick out that common ratio much faster. So 0, 1, 1, 4, 2, 16. Oh, okay. So 0, 1, again, here's our A. Our B value, how are we getting from one y value to the next? What are we multiplying by? So from 1 to 4, I multiply by 4. From 4 to 16, I multiply by 4. All right, so our B value is 4. What's that common ratio? So writing my equation, filling in A and B, and raising it to the power of x. All right, which does that make sense? Absolutely. This is a growth graph. You can see from left to right that we're increasing. So our B value should be greater than 1. Last but not least, taking a look at number 10, just picking out some nice clear points for us. Ooh, we had those 2 really nice ones, and now we've got a couple down here to help us out. Okay, so I'm going to put these in. Even though they're a little spread out, I should still be able to get a pretty accurate idea of what the common ratio is. So the first one is -4, 15. Don't mind my table, by the way. -3, 10. And then we jump down to 0, 3, and 1, 2. Okay, so I should still be able to pick out a common ratio here. First thing though, 0, 3, that gives me my y-intercept. So A is 3. All right, so my B value, what's my common ratio? Well, first let's think about how did I go from 15 to 10? What did I multiply by here? So 15 down to 10. So it looks like multiplied by 2/3. Does that sound about right? And again, in order for us to accurately figure that out, we can take 10 divided by 15. Yep, and this reduces to 2/3. Let's make sure we've got the same thing here. What did I multiply 3 by to get to 2? So again, work backwards. 2 divided by 3, yep, equals 2/3. Okay, so it looks like our common ratio here is 2/3. All right, so writing our equation, filling in A and B and raising it to the power of x. We have our final equation for number 10, which makes sense. Our B value being 2/3, it's between 0 and 1. We know that this is a decay graph because from left to right, our graph is decreasing. All right, so taking a look at number 11. Now these you can either do by hand or you can use your calculator. Calculators are just so beautiful. So which ordered pair is in the solution set of y equals 3 to the power of x? So if you want, you can actually plug this right into your calculator and you can take a look at your table of values and pick out which point listed here is actually in your table of values. So if you want, go ahead and take a second and do that. You're also more than welcome to do all of this by hand. If you wanted to actually say, okay, so if I plug in 0 for x, so let's see, y equals 3 to the 0 power. Well, what's anything raised to the 0 power? 1. So this ordered pair would be 0, 1. Is that what we were given? No, we were given 0, 0. So that's obviously wrong. 3 to the 3rd power, does that give me 1? Nope. Okay. So again, you can go ahead and plug these in by hand, or you can look at your table of values in your calculator. And it looks like the only one that is actually on that table of values is number 4. 3 to the 4th power gives us 81. Same deal. Which ordered pair is in the solution set of y equals 5 times 2 to the power of x? Once again, you can plug this right into your calculator. You can take a look at the table of values. I would plug it in exactly as you see it. 5 parentheses 2, close the parentheses, raised to the power of x. You are also more than welcome to do all of this by hand. Remember, exponent comes before multiplication. But for me, I'm looking at the table and I'm looking at all these ordered pairs and I'm saying, all right, which ordered pair do I actually see on the table for this particular function? The only one I see is number 3. And again, we could do that by hand just to verify. So I plugged in 3 for x. I want to see if I come up with 40 for y. 2 cubed gives me 8. And 8 times 5 is 40. So yep, number 3 is the only one that works. All right, there's notes number 2. We're just going to keep moving along here. Tomorrow we're going to compare linear functions and exponential functions.